Dear students, our topic static and dynamic memory allocation. We are comparing static memory allocation and dynamic memory allocation on behalf of array and linked list. We all know that array is following static memory allocation and dynamic memory allocation is done by the linked list. Okay, so we are discussing about the static and dynamic memory allocation. So let's start. So let's assume that this is our linked list, name LL, okay, and this is our array, okay, for integer. So it is an integer array and it is integer linked list. First we are going to explain about our array static memory allocation. When we are declaring a array about like this int a of 10 semicolon, and after compiling this statement in our program, our memory allocation should done like so this is a of 10 means 10 into this integer for each integer value we want 2 bytes, is it? So total 20 bytes should be allocated by our memory management system after compilation. So after compilation itself we will get that 20 bytes. Okay, so this is our that memory for that a of 10. Okay, so these are 20 bytes are the 20 locations are the for saving 10 integer elements for array A. That is our static memory allocation. So static memory allocation is allocated at the time of compilation itself. Okay, after compilation we will get the correct memory space for storing our data for our program. So this is the static memory allocation. Let's assume that we want to store 3 values like 10, 11 and 12. Okay, so first 2 bytes is using for storing 10 value 10 and second 2 bytes is for 11 and another 12 is stored in this location. Okay, so we are using 2 bytes for storing one integer value. That is, we all know about that, because for saving an integer value at least 2 bytes are just needed. So total, when we are just assume that our memory location is starting with 1000. Okay, 1000, 1001, 1002, 1003, 1004, like it is 2090. Okay, so this 6 bytes is using to store the value 10, 11 and 12. But at the time of compilation itself, we will get the total 220 bytes for our program execution. Okay, so in this situation, the remaining 14 bytes are useless. Okay, so that is the static memory allocation. And when you are going to the linked list, dynamic memory allocation. Dynamic memory allocations means after compilation, we are not getting the memory for storing the data. We will get the memory after the execution of the program. We all know that for linked list, for each node structure, there is a struct. Is it? So so this is our structure for int data for saving the data and another, okay, and the link to the next node. Okay, struct ll next star next. Okay, so this is our node structure. So this portion is the structure of each node. This we have explained detail in our previous videos. The link should be in the description box. Okay, after executing this statement, we want a data part and the link part. Okay, so it is an integer data part, so we want 2 bytes for saving the integer data part and for another 2 bytes to save the link of the next node. Okay, so total 4 bytes are needed to store the detail of one node of the linked list. So these are the 3 memory portions. For array, we want 20 consecutive memory, contiguous memory for this a of 10, this a of 10. But for linked list, for one node, this 4 bytes we needed continuously. But there is no need to save the data after this. So there is no need to have the memory that is contiguous to this 4 bytes. We can locate, we can store the data in any other location in the memory. So there is no need of contiguous memory in dynamic memory allocation in the case of linked list. We want this 4 bytes contiguous for first node. This for our first node, and this is our second node memory space, and this is our third node memory space. Okay, so let's assume that this is our 100 and 101, 102 and 103. This is like 200, 201, 202 and 203. Okay, so there is no need of after 103 the second node is in the location 104. There is no need of that. We can store in any other location. So and this is, let's assume 300, 301, 302 and 303. Okay, so for each node we want 4 bytes, and this 4 bytes should be in contiguous fashion, but the another 4 bytes for the second node, there is no need of the contiguous memory space. So let's assume that we are saving 10 here. Our first node containing 10, our second node containing 11 and our third node containing 12. This is our start or our head point. Okay, this is pointing to our first location. So our first node starting 100 is 100. So this is our 100. So our start pointer is point to our first node 100, and the second node is at the location. See, second node is at the location 200. Okay, and third node starting address is 300. Our linked list should be like this. This link part containing 200, the starting node, the address of the third node, second node, and this is 300, the address of the third node, and this is the null value -1. Okay, for the null value. So our in the memory data should be like this. This 2 byte is for saving the value 10, and this 2 bytes for storing the memory address of the second node, that is 200. Okay, so 2 bytes are needed to store an address value. Okay, so total 4 bytes is needed for the first node, and the second node is containing the data value 11 and the link part containing the address of the third node 300, and the third node containing the data 12 and the null value. Okay, so this is our null value because this is not a correct address value. Okay, here also we want 4 bytes. So total 12 bytes is needed for saving the 3 nodes of this linked list. Okay, we already discussed our insertion of the linked list. So in that program we have discussed about malloc statement. So in the statement the memory allocation should done at the time of executing the malloc statement. So after each malloc statement we will get each node memory address. Okay, so after first execution or first executing this particular program or particular code, the 4 bytes for the first node should be allocated to us. Okay, and after executing, then again we want another node, we will again execute this malloc statement, then we will get the another 4 byte, and then another if we want the third node we will get another 4 bytes. So, okay, if we want 3 nodes, then we will get 12 bytes for storing our data. Okay, so this is only we will get each node address or each node memory space only executing the malloc statement in the program. But in the case, this is this dynamic memory allocation. But in the case of static memory allocation, at the compilation itself, we will get that 20 bytes. But in this, we will get only 12 bytes after creating all the nodes. Clear? So this is dynamic memory allocation and this is static memory allocation. So here we are using 6 bytes for storing the data. Here only we are using 12 bytes, but for each for saving one data we want 4 bytes. So because we are also saving the address value of this next node, but here there is no such cases because it is in the continuous memory location. So this is the comparison of the array and linked list memory allocation. So according to this, we will just discuss what is the difference between static and memory allocation. So static memory allocation example is arrays. Memory is allocated during compilation. So it is fast also. Here the example is linked list and memory is allocated during execution. Hence it is very slow when compared to the array execution. Okay, memory is allocated only once. After compilation, if we are executing like our declaring a of 10 for integer array, we will get 20 bytes at once. Okay, but the memory allocation is many times. First we will get the 4 bytes for the first node, next we will get 4 bytes for the next node, and next we will get the 4 bytes. Here the memory allocation is like this. So memory should be in continuous, but memory is not in the continuous fashion. There may be wastage or shortage. If we want to store 3 data we only want 6 bytes. So another 14 bytes are shortage. So there may be shortage or wastage of memory. Okay, it is difficult to predict the exact memory requirement before the execution. There is no possibility of wastage or shortage because the memory allocation is at the time of execution. So only we are getting the memory that only we want. Okay. Insertion and deletion may take some time as it requires shifting of elements. We have already discussed the insertion and deletion of the array algorithm. In this, we are shifting. If we are inserting in a particular position, we want to shift that the remaining data down, and for deletion we are shifting the data up. Okay, so insertion and deletion is fast as it required changes in one or two addresses. For insertion and deletion of an linked list, only we need to edit the address part only. Okay, so it is fast. Searching is faster as binary search could be used. In array we can use binary search, but in linked list it is difficult to implement binary search. So it is searching is slow, and we have already discussed, like in day of 4 means 8 bytes of memory is allocated for array A, and here the memory is allocated only once, but 4 elements we let's assume that we want 4 elements, so we need 16 bytes, so 4 bytes for each node. Hence more memory is required because not only we store the element but we also store the address of the next element. So for storing each value, here only 2 bytes is needed. Here 4 bytes is needed for 4 bytes is needed for storing one value. But when compared to linked list, programming is easy, and when compared to array, programming is not easy in the case of dynamic memory allocation or in the case of linked list. Okay, so this is all about the comparison of the static memory allocation and the dynamic memory allocation. Thank you.